We're gonna have eyes on, protective gear, okay? If you're handling anything that involves a flame or any toxic chemicals that might spill on you. We wanna turn on the gas, and you wanna make sure that this window is closed by turning the collet ring, and that's all it takes to start your Bunsen burner. You can then turn your ring down here to create a hotter flame. Make sure your stem is not getting unscrewed in the process. Watch the pipes, because this does tend to drag your Bunsen burner. So we're gonna use this. This is, what do you guys call this?
Inoculation loop.
Okay, inoculation loop. We call it a flame wand, okay, in physiology. In micro, you would call it an inoculation loop. What we're gonna do is we're gonna clean it by just a little bit of hydrochloric acid and just dissolving any residue, that all the colors kind of burn off in there. And what we're doing is we're gonna take one stable ion at a time. Remember, a stable ion is one that has given up the electron. We're using all cations, given up one or two of its electrons to emulate its neighbor on the periodic table. That's a rare gas. In this case, we're using strontium, and strontium will give off a very characteristic color when you heat up those very stable outer electrons, and then as they cool off, they will liberate the extra energy they got in this from this Bunsen burner in the form of light. So let me know when you see that color. That's very characteristic. Takes a little while for it to generate, but when you see it, you won't miss it. There's no denying it. Okay. Are you guys seeing the sparks of red in there?
Yeah.
Okay, of course I'm kind of missing it there. Here we go. I think these safety goggles are altering my depth perception. Has anybody seen the red now?
Yeah.
Okay, all right, very good. Okay, so then we'll go ahead and just put it in the cleaner again and just get rid of that residue. Let it burn off. The orange flame you're seeing there is just a little bit of tungsten, which is what this wire is made of. Now we're going to use potassium. Now, what I'm going to do before I do potassium is, if you guys can just take a couple of these to your table, please handle them carefully, put them on your book. What this is a cobalt filter. Okay? So, you want to take one? And just be careful with it. And if you guys want to take a couple to your table. Do you guys have one? You've done one, too. And what this is it's a very short flame. You know, it lasts for a very short time with the naked eye. But when you look at it through the cobalt filter, you'll still see it. And what you see is a pink flame. So don't hold it up to your face yet, okay? You'll see it with your naked eye, and when you don't see it anymore, go ahead and hold it up with look at it through the cobalt filter. So there's no denying this color change, right? When it happens, right? Mm-hmm. Okay, that pink flame. Now keep looking at it when it goes away, and see if you can still see it through the cobalt filter. Can you see it? You should still be able to see it as a pink flame. Okay, so if you haven't had a chance to do it, I'll go ahead and do it one more time so you guys can give somebody else a filter. Okay, so once again, with the naked eye, you should be able to see that very dramatic color change, but it's short-lived in that you can't see it with the naked eye anymore, but take a look at it when you can't see it anymore with the cobalt filter. Do you see it still? Very good. Okay. Can somebody give me a cobalt filter so I can also, or actually give it to her so she can you put it in front of the camera? Okay, not right now. Okay, right now you see the, hold on. Right now you see the pink. And when you don't see the pink anymore.
There you go.
Okay, now go ahead and see it with the, should still be able to see it, even though you cannot see it with the naked eye that well anymore. All right? Take it away. There you go. So, all right, excellent. The next thing we're going to do is copper. Now this is an unknown, so it's copper with something else, but there's no denying copper because it's a very characteristic flame color. Tell me when you see it.
Green.
See the green? Let's do it again. Okay, very nice. Ooh and ah. Okay, very good. Okay, now the last one we're going to do is sodium. Now I save sodium for last for a reason. Sodium tends to act almost like a contaminant and everything. I mean, a lot of times flames are yellow, like in a some sort of a wood fire or whatever, because there's a lot of sodium in there. The sodium on the dust and everything else. So there's no denying sodium when you see it because it has that really, really heavy, overpowering yellow gold color. See that? Okay, that's all sodium. So it doesn't have that orange flame that you would expect out of burning tungsten. This is all sodium burning. Okay? Any questions? Okay. So that's your flame test. So what we're doing here basically is taking the outer electrons that are very stable now because you've lost the ions that you needed to lose to make a very stable atom system. And then what you're going to do now is go ahead and heat it to the point where it is going to take those electrons and try to get them out of the orbits. But that's not going to happen because they're too tightly bound in a sense to the nucleus of the atom. So as a result, they'll have to cool off again. And as they cool off again, law of conservation, of matter and energy, in this case energy, you can't just say the energy dissipated. It went somewhere. Well, what it went into was light, okay? And that's why you see the light. And it's characteristic of the cation you are burning, okay? Go ahead and you can stop it now.